Review of writing a simple exponential equation from the table below. Now, I say simple exponential equation because we're sticking with y equals a times b to the x. It's not going to get any more complicated than that, what we're working with right now. And the other thing that's important to note is that the step is 1 in this case. So the step is 1, as in we're going from x is 1, 2, 3, 4. It's not going x is 1, 4, 7, whatever. So the step is 1, and we're going to be in this this form. So let's get going then. If this is in fact what we need, then these are the only two things that we need. This is the growth factor, and A is the starting value. A is the starting value. So whenever you're finding these, it's usually best to start with your growth factor. Start with your growth factor, and what is the growth factor? That is just what we're multiplying by each time. So you're asking yourself, what are we multiplying by every time we take a step? Now that's another important part to why I said, okay, the step is 1. It's going to make it a little bit simpler for us because we can just kind of look and say, okay, well, from 5 to 10, from 10 to 20, from 20 to 40, what's happening? We're doing times 2 each time, times 2. And if that's the case, then B is 2. That's kind of easy to spot in this case. If you cannot spot that, you can also set up a little equation. 5 times B must be 10, right? 5 times B must be 10. Well, then if I solve for B, then B is 2. That works for any of them because we're talking about one step. So from 40 to 80, 40 times B must be 80 because we're multiplying by B once to get here. 5 by 40, and B is 2. So however you want to go about getting that, you'll see in the next, I'm going to provide another example right after this that's going to show you when that is going to be in handy, because it's not always going to be so easy to spot 5, 10, 20. Like I can see that that's 2, but it's not always going to be like that. What if it were times 5/6, right? That would not be easy to spot. So there we go. We have B is 2. Now we need A. It's our starting value. What do we know about A's starting value? Can I just say, oh, starting value is 5? That's the first one they listed. No, I cannot. Why? It's because the starting value happens when x is 0. Note that if you don't have that. Starting value is when x is 0. Very important. You can't just take any, like the first one listed. X is 0 is what we need. So we're talking, it has to be back here. So if we're multiplying by 2 every time we take a step, that means something must have been multiplied by 2 to get to 5. So you can set up another equation if you want. Something, or you could call it A, or you could just call it X. Something multiplied by 2 must have been 5. Okay, so how do I solve then? I got to divide by 2, and X is 5 halves. 5 halves or 2.5, same thing. 5 halves, 2.5, same thing. So you can think of it, you can set up the equation x times 2 equals 5. So some number multiplied by 2 must have been 5. So we got to divide to get there. Or you can kind of think of it logically like that as well. If we're multiplying by 2 each time this way, then we're dividing by 2 each time we take a step this way, right? 20 divided by 2 is 10. 10 divided by 2 is 5. And 5 divided by 2 is 5 halves. 5 halves or 2.5, whatever. Then you're just plugging it into the equation, right? Y equals a times b to the x. So y equals 5 halves times 2 to the x. Okay, there's the equation. That's your final answer. I've got a starting value. I've got a growth factor. That growth factor came from what are we multiplying by? Starting value came from what's that value from the function when x is 0. So let me give you one more example because this one isn't so obvious. 4 times what is 10? 10 times what is 25? 25 times what is 62.5? I don't know. It's not so easy. This one I could be like, oh, okay, 5, 10, 20 times 2. Easy. But we're looking for the same stuff. So a times b to the x. Now here's where we have to use that strategy. We have to say, 4 times b must have been 10. So just remember, we got one step here. So one for x is 1 to 2. So we only multiplied by b once. So 4 times b must have been 10. Okay, let's solve then. We know how to solve a simple equation like that. Divide by 4, and that equals 1. So we're left with 1b. And 10 fourths is b. Perfect. So what does that mean for a? A means we've got to find when x is 0, right? So we're not quite there. It's not 4. So we have to go backwards 1. Now, again, you can, if you want, set up an equation and say, I've got some number here that I don't know, must have been multiplied by b to get to 10. No, sorry, to get to 4, which is the first one listed here. But we know b is 10 fourths. Sorry, b at some number times 10 fourths is 4. Man. All right, is 4. So in order to solve for this, you can either multiply by 4 and divide by 10, or we can just say, let's divide by 10 fourths. Divide by 10 fourths. And if you remember, 4 divided by 10 fourths, we've got to flip this because we're dividing by a fraction. So 4 times 4 tenths. 16 tenths, 1.6 if you please. And there you go. So y is 1.6 times 10 fourths, or, that's 5 halves too, to the x. If you want to simplify that, that's 5 halves. But there you go. There's the equation. And, these numbers aren't so obvious, but we're following the same exact kind of thing. 4 times a number times b must have been 10. 10 times b must be 25. And then, if we're multiplying by 10 fourths or 5 halves each time this way, then we must be dividing by 10 fourths each time this way. So 4 divided by 10 fourths, as we said, 4 divided by 10 fourths. Flip reciprocal here, multiply, and you get your answer. And that's how you write a simple equation here. We're finding the growth factor, we're finding the starting value, and then we're just plugging it in.